In today's video, here is a very nice problem from Bulgarian Mathematical Olympiad edition 2008. So here is a nice equation involving the floor function. So here is the following equation. We have x squared minus 13 is multiplied by the floor of x plus number 11 equals 0. Okay. Here is a definition of the floor function. We have greatest integer less than or equal to x. Okay. So we have this inequality. X lives between n and n plus number 1. So the value that x is going to take is n, not n plus number 1. It can go all the way down to the n plus number 1, but it does not include n plus number 1. So here is a few examples. We have the floor of 1.99 equals 1. We're always growing the number down, okay, to the lowest value as an integer. So for the negative number, it's a little different. So if you have put minus 3.99, if you have a positive here, it's going back to the lowest one, which is 3. But since we have a negative, it's going to minus 4. Because the minus 4, that's the lowest value for that one. It's not minus 3, okay, minus 4. So we have a floor of 5 equals 5, because this is if x is an integer. In order to solve this equation, I'm simply going to replace this floor of x with n, okay, as an integer. So this is the only information that we can use to solve this equation. So this is enough information that we have. So let's go through this one. We have x squared minus 13 n plus number 11 equals 0. Okay. So I'm going to move over these two terms to the right. I get x squared equals 13n minus 11. So we have a nice observation here. If you take a look at this x squared, so this one is telling us this term is positive. Okay. This is very nice information. This one can help us to avoid all the negative numbers. Okay. So since this one is a super equal to 0, which means 13n is super equal to 11 equivalent, n is super equal to 11 over 13. You know this number is strictly superior than 0. Since we have n as a natural number, this one is telling us n must be super equal to 1. Okay. We don't have to worry about the negative numbers at all. Okay. Since we have n super equal to 1 here. So I'm going to take this information down here. So we have n is super equal to 1. Now I'm going to make the combination, this one and the inequality. Okay, this inequality. So the only difference here, we need to raise number 2 as a power on both sides, since we have n as a positive. Okay, so we know n is inferior equal to x and x strictly inferior than n plus number 1. So I'm simply going to raise number 2 as a power on both sides. I get here n squared is inferior equal to x squared is strictly inferior than n plus number 1 quantity square. Okay, keep in mind here is super equal to 1. Okay. Now the nice thing here, now what I'm going to do now, I'm taking this value of x squared and then replace it between this inequality. So which means I get here 1 is inferior equal to n squared is inferior equal to 13n minus 11 strictly inferior than n plus number 1 quantity square. Okay. Now we have two things here. I'm going to divide this inequality into two inequalities. So I'm going to work on this one, and also I'm going to work on this one like this. Okay. I'm going to work on each one separately. By taking the purple one, I get here n squared is inferior equal to 13n minus 11, which is equivalent. By taking these two terms to the left, I get here n squared minus 13n plus 11 is inferior equal to 0. Okay, this is the first inequality. The second inequality, which is red one, I get here 13 and minus 11 is strictly inferior than n plus number 1 quantity square. By distributing this one out, I get n squared here plus 2 times n as a middle term plus number 1 as a last term. Okay. Moving over all these terms to the right, I get the following inequality. I get n squared plus 2n minus 13n, which is minus 11n. I get here 11 plus 1, which is 12, which this one is going to be strictly superior than 0. Okay, so let's put this one as a red inequality. Now I'm going to take this both inequalities at the top and continue solving our inequality. Since we have both inequalities, they are going in different directions, so we are going to check what's the status of this one, what's the status of this one. Okay, to find n. If I find n, I will be able to solve this equation, because the value of n is telling us the value of x. Okay, because the value of n is telling us the floor of x. The floor of x, that means is telling us the value of x. Okay, so the value of x in the floor function, sometimes it could be the value itself, sometimes it could be inequality, so that means the x lives in certain interval. Okay, so I'm going to start with this one. Let's call it inequality number 1. This is inequality number 2. Okay, let's define the function. Define f of t of t equals t squared minus 13t plus 11. Okay, and let's define also g of t equals t squared minus 11t plus 12. Okay, we have two different functions. I'm going to study each function separately, then I'm going to put them together in one graph to see where I have a solution for each one. Okay, let's start with the first one. If you take a look carefully at both functions, since we have the minus sign here, which means this function is going to cross the horizontal axis at some point because of the negative number here. So this means there is an intersection between this function and OX axis. The same thing with this one. Okay, so which means I will have an upper face parabola here. But I'm going to calculate the first derivative function of this one. Before I'm going through the differentiation of this function, I'm going to solve this equation to see where I have an intersection with the OX axis. The same thing with the other one. So if f of t equals 0, equivalent t squared minus 13t plus 11 equals 0. I'm going to calculate the discriminant of this one. We'll have delta, which is 13 squared minus 4 times 11 is giving us 169 minus 44, which is 125. So I will have I have two solutions here. T1, which is 13 plus square root of 125. As we know, square root of delta equals square root of 125, which is the same as 5 is multiplied by square root of 5, because we have 25 is multiplied by 5. So we'll have here 5 square root of 5 divided by 2. The second value, I get T2, I get 13 minus 5 square root of 5 over 2. I'm going to check the value of this one. I get here 12.09. I get here 0.9, like this. Okay, I'm going to do the same thing with the second one. So we'll have g of t equals 0, equivalent t squared minus 11t plus 12 equals 0. Equivalent, I'm going to calculate the delta of this one. 11 squared, which is 121, minus 4 times 12. You get 121 minus 48 is giving us 773. Okay, so we have also two solutions here. T1, it gets me 11 plus square root of 73 divided by 2. The second solution, I get 11 minus square root of 73 divided by 2. I'm going to check the value approximately. It is giving us 9.77 approximately. The other one is giving us 1.22. Okay, like this. I'm going to take this value that I found and put them on the side and continue with the inequality. As we solved that equation, we found the following solutions. We found two solutions for the first one. We found two solutions for the second one. Now we found also the intersection points these functions with the OX axis. Okay, what's the other thing coming up? So before I go to the graph, I'm going to calculate the first derivative function of this one. As we know, we have f prime of t as the first derivative function of this one is giving us 2t minus 13. If I'm going to solve this equation, I get t equals 13 over 2. So I'm going to calculate f of 13 over 2 is giving us minus 31.25. For the second one, I get g prime of t is giving us 2t minus 11 equals 0. If I'm going to solve this equation, I get t by finding the roots of this one. I get t equals 11 over 2. Okay, so I get here g of 11 over 2 is giving us minus 18.25. Okay, now I'm simply going to take the general picture of this one. So we get here for the first function, which is f of t, I get 0.9. 0.9 is going to be here. Let's put it as a t2. Then I get second point 12.09. 12.9, it can be here around this point. We know t equals 13 over 2, 13 over 2, which is 6.5, almost the half of this one. Minus 13, minus 31.25 is going to be like this. So we will have upper face parabola. The general picture of this one like this is going this way. This is the function c of f. Let's check c of g. So I have the intersection points with OX. I get 1.22 and 9.77. 1.22 is going to be like this here. Let's call it as T4. T3 is going to 9.77. Is going to be here. Then I will have so for this one I get 11 over 2, which is 5.5. It's going to be almost at this point. So the output of this one is giving us minus 18.25, which is going to be around here at this point. I will have also upper face parabola. Okay, now if you take a look carefully at this graph, so the solution for the first function, which is f of t, is going to be underneath of this one, which is a red one, because this one has to be inferior to 0, which means including this point 22 and t1, but in this area below this OX axis. But for the other function, g function, so we'll have above OX axis as our solution, because we have strictly superior than 0, which means where we have this one is strictly superior than 0. If we move on to the left in this area, and if we move on to the right area, because above these points you get the function g of t is above the OX axis. But we're going to take the solution for this one as an intersection of two functions. So the intersection for this one, since this it will be this area, this is the solution. Okay, this area. Let's put it in different color to make sure this is our solution. Okay, the intersection for the f of t function, I get t is between 0.9 and 12.9, which means since I have n as an integer, let's put it n1 is belongs to this set. Since we have the n as an integer, we are going to take the following values of n: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. For the g function, the solution for this one, I will have 1.9 and 1.22. Okay, has to be in this direction. So for the other one, I get here this one, the another solution. I get here T3, which is 9.77. The other one is the maximum is 12.9, like this. Okay, so the solutions for this inequality, so the intersection of this f of g, f and g, is given as the following. Since we are dealing with the integer numbers, so we know t is between 0.9 and 0.22. So since n is an integer, which means the solution I will have number 1 for this one. Let's move on to the second interval, which is this one. I'm going to take the following values. I will take 10 and 11 and 12. So I will have 4 different values for n. This is the solution. This is the solution for this inequality. Now let's take this one at the top and find x. Okay. For the first solution, we have n equals 1. Now I'm simply going to replace n with number 1. Okay, to find x. We get x squared equals 13 minus 11 is given as 2. Okay, but 2 solutions here. I get x equals plus or minus square root of 2. Okay, let's call it the solution number 1. If n equals 10, I get x squared equals 13 is multiplied by 10, which is 130. 130 minus 11 is given as 119. Also, I get 2 solutions. x2 equals plus or minus square root of 119. Okay. For n equals 11, I get x squared equals 13 is multiplied by 11 minus 11. So I'm going to use the trick. I'm going to take 11 as a common factor here. I get here 13 minus 1 is multiplied by 11. 13 minus 1 is 12. 12 is multiplied by 11. We know 11 is multiplied by 11 is 121. Okay, since we have 12 here, we are going to add another 11, which is 132. 132. So without using the calculator, you can calculate it easily in this way. Okay, so I get here x. I will have 2 solutions. Square root of 132. This one is telling us plus or minus 132 is 4 is multiplied by 33. Okay, which is 2 square root of 33. So for the last one, I get n equals 12. N equals 12 is given as x squared equals 13 is multiplied by 12, 11. Okay, so I will have 13 is multiplied by 12 minus 11 is the same as minus 12 plus number 1. Taking 12 as a common factor, I get 13 minus number 1 plus number 1, which is 13 minus 1 is 12. 12 is multiplied by 12 is 144. 144 plus number 1 is given as 145 without using the calculator. Okay, so we get x equals plus or minus square root of 145. Okay, so here is a problem. Here is something very important. If you don't pay attention to that, it takes you quickly to the wrong answer. Okay, so this one, if you have a negative solutions, is verifying for this equation because you have x squared here. That's why you put plus or minus. If you look at it at one side, if you look at it on both sides, then you find what is a problem. So if you check the floor of x and you replace the negative solutions, it will not verify this equation. Also, if you remember, we already proved n is super equal to 1, which means the floor must be positive. Okay, which means the floor of x must be positive integer. Okay, based on this proof. So which means we are going to cancel out the negative solutions. I will be left only with positive solutions. Okay, now, so I have undo this video. If you have any question or suggestion, Just put it in the comment section below. By the way, consider the subscribe and like. Thank you for watching. I will see you next video. Bye.